Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on circle geometry again, which is Euclidean geometry for mathematics grade 11. And this is Theorem 6, which says tangents from same point equal. We have a lot to cover, so let's start. In summary, we're going to look at step number 1, what the theorem is about, know your theorem, and then number 2, we're going to look at the second step, which is figuring out what the goal is, what are we required to prove. And number 3, we're going to look at step number 3, which is the strategy. How do we go about showing what it is that we need to prove? And number 4, we're going to look at how to apply theorem number 6 using examples from past exam papers. Let's start. First of all, step number 1 is to know your theorem. Whenever you need to prove a theorem, the first step is to know the theorem, because if you don't know the theorem, then you won't even know what it is that you need to prove or how to prove it. So step number 1 is know your theorem. Always know your theorem. Some theorems are very easily stated, so there's no need to define words. You will understand everything without any problems, but some have words that you need to understand because they are intricate and important to the theorem. Now, the theorem says two tangents drawn from the same point outside of a circle. Then the statement goes, if two tangents are drawn from the same point outside a circle, then they are equal in length. A tangent, let's define that first of all. A tangent is the line that cuts the circle at only one point or touches. Line touching, line touching circle at circumference. Touching circle once, and that is at the circumference. That is what we call a tangent. Now, the line that touches or cuts the circle more than once is what we call a chord. Okay, so two tangents, if two tangents are drawn from the same point of a circle, then they are equal in length. So what exactly then are we supposed to prove? This brings us to step number 2, the goal. The goal is to prove that these two tangents drawn from the same point are equal. In this case, AP is equal to BP. That is what we are required to prove. The AP equals to BP. Now, the strategy, how do we go about proving this? What is the strategy that we are going to use? Now, the strategy we're going to use here is very easy. It's the strategy we use for many of the theorems that we're proving so far, and the strategy will be simply congruency. And in this congruency, here is what we're going to do. So we've got common equal radii, and then we've got a common line, and then we've got angle OAP equals to 90 degrees. And the reason why that is the case, it's because of, you will see in a moment. So we will be using side angle side as the strategy to prove this angle. So now let's start. In triangle OAP and triangle OPB. In triangle OAP and triangle OBP. Notice the order. Okay, we've got OA is equals to OB, equal radii side. OA equals to OB, and the reason is equal radii, and this is the side. Next, we look at the angle OAP is equals to angle OBP. Angle OAP equals to angle OBP, both equal to 90 degrees. And the reason is the tangent is perpendicular to the radius. Tan perpendicular to radius, that is the reason. So that is 90 degrees. And then we've got OP, which is a common side. OP is equal to OP. And the reason is common or common side. It's up to you how you want to write that. You don't have to write side, you can just write common. Therefore, these two triangles are congruent. Therefore, triangle OAP is congruent to triangle OBP, and the reason is side angle side. Now, therefore, it means that angle AP is equal to angle BP. Therefore, angle therefore angle side AP is equal to side BP. And there is your proof. The construction is very easy. You join OA and connect OP. Join OA and OB. Construction, you join OA and OB and OP. That's what you do. And we are done proving. It's a very easy theorem to prove and quick. So now let's look at some questions from past exam papers that use this theorem. Now question number 10 goes, this is from the November 2017 paper 2 of the Department of Education, CAPS. M is the center of the circle SVQR. So this is M, that is the center of the circle, and the circle is circle MQVR. MQVSR. Okay, SV, that is SVQR. There is the circle. Those are the vertices that touch the circle. Having equal chords as V and QR, these are the equal chords. RP and QP are tangents to the circle at R and O respectively. These are the tangents, QP and RP, such that angle RPQ, the angle formed by the common point where they meet, is equal to. Now calculate the size of angle R2. Calculate the size of angle R2. That's what we need to calculate. Calculate the size of angle R2. All right, let's look at this question. Now let's separate this so that we can work. All right, so 10.1. We are supposed to calculate the size of RP. 10.1. Let me fix that. 10.1. 10.1. We are supposed to calculate the size of angle R2. All right. First of all, angle R2. Let's reduce angle R2. That's what we're supposed to find the value of. Now, first of all, let's state that side QP is equals to side RP. Side QP equals to side RP, and the reason is tangents from same point. Tangents from same point. Tangents from same point. Okay, now that we've got these equal, therefore the base angles will also be equal. Therefore, angle R2 will be equals to angle, I think that is angle R1, angle Q2. Angle R2 is equals to angle Q2. then you can just simply say QP equals to RP, or you can just say angles opposite equal sides. It's up to you how you want to do this. I have different ways that I do it. All right, now, but notice that angle R2, but angle R2 plus angle Q2 plus angle P, they add up to 180 degrees. And the reason is sum of angles in a triangle. Sum of angles in a triangle. Therefore, angle R2 plus Q2 is equal to 180 degrees minus angle P, which is given to us as 70 degrees, and there is this size of P. That leaves us with 110 degrees, meaning that therefore angle R2 is equals to angle Q2 is simply equals to 110 divided by 2, and that is 55 degrees. And that is how we find the angle of that case, and the reason is so angle R2 is equals to 55 degrees, and that's how we found the size of that angle. Now find the size of angle Q1. Q1 is the angle that is subtended, okay, close to the angle that is subtended by the angle at the center of the circle. All right, now okay, so now, all right, this angle Q1 plus Q2 is equals to 90 degrees. So let's find the size of that angle. Let's extend this so we can have enough space to work. 10.2. We are looking for the size of angle Q1. Notice that angle Q1 plus angle Q2 is equals to 90 degrees, and the reason is radius perpendicular to tangent, angle R1, Q1, plus angle Q2, that is equals to 90 degrees, and the reason is tangent perpendicular to radius, tan perpendicular to radius. Therefore, angle Q1 is equals to 90 degrees minus angle Q2. We already know what angle Q2, the size is. Angle Q2 is equals to angle R2 is equals to 55 degrees. Therefore, angle Q1 equals to 90 degrees minus 55 degrees, which is equals to 35 degrees. If you're not sure, always make sure that you use a calculator. That's what I do. Always make sure you use a calculator there. So that is 35 degrees. So let's pencil in the angles. So this is 55, and that is 35 degrees. Next, determine the size of angle M2. The size of angle M2. The size of angle M2. Notice that angle M2 is equal to angle M1, and the reason is vertically opposite angles. All right, so size of angle M2. So if we can find M1, the size of angle M1, we will be easily finding the size of angle M2. So now angle M2 equals to angle M2 is equals to 180 degrees minus angle Q1 plus angle R1, and the reason is sum of angles in a triangle. R1 plus Q1. And the reason is sum of angles in a triangle but we know, therefore angle M2 is equals to 180 degrees minus, but R1 equals to Q1, but R1 equals to Q1, but angle R1 equals to angle Q1, and the reason is angles opposite equal radii, and here are the radii. The radii are MR and MQ. Therefore, angle M2 equals to 180 degrees minus R1 equals to RQ1, so that will be 35 plus 35, which is 70 degrees. 35 plus 35, which is equals to 180 minus 70, leaving this with 110 degrees. Therefore, angle M1 is equal to 110 degrees. And this is how you get to the end of the video. Thank you so much for watching. I'll see you in the next one. Bye-bye.